So we know that we should prefer using things like memchr or any standard function instead of loops if they behave the same. And the reason for that is, apart from bugs, it's probably more tested than your loop. It's because it's probably faster. And why is that? Well, let's look at this implementation of memchr. So here, again, memchr, if you didn't know, it's a function that takes a void pointer, a character, and a size. So within a memory region S with size of n, so n bytes in S, we're trying to find a character C. So in this implementation, we're looping until we have run out of n for a character C. If we found that C, we'll return the pointer to that, otherwise we return null. So this function is O n, right? The worst case, because we are examining every possible character. However, what we can do is something like this. So instead of examining every character, what we can do is examine more than one character at a time. So this function is, the worst case is O n divided by, well, the bytes, the amount of bytes we're examining at once, right? So O n divided by the size of word. So here we are using size t. We're using main alias because the compiler assumes that when you use a pointer and when you dereference with a different type, well, you can't really do that, so we're using main alias. And we didn't align the pointer, which you should. So you shouldn't copy this code. we're just using this for example. So as is aligned, but here we have word, which is a type def to size t, and we have star word, which we're going to use as the word that will store the, well, in this case 8 bytes from the string. And then we have char word, where for every byte we will have C. So here we should probably have some sort of function that will distribute C to word. I don't know. We should have some sort of function to do this, right? And then we change this to be n is larger than size of word, and if it is larger than size of word, then we will examine 8 bytes from the string. But first we will dereference the pointer with the type word, and then put it into the star word, where we will use star word, and then the char word, and then we will check if we have a byte that matches from char word and star word. And then if we have a match, then we'll just do a normal loop. Of course, this is not the only way. You can also check the location of the match in parallel instead of a loop here, but for the sake of simplicity, I'll just leave it like this. So in this case, instead of examining every byte, we're examining every 8 bytes. But if you use this and compare it with memchr, it will still be slower than the glibc memchr. But why is it slower? We have examined more than 1 byte at a time. Well, apart from techniques like loop unrolling, well, we have a thing called SIMD, single instruction multiple data, where we are doing the same instruction for multiple data. Multiple data here refers to an array of values. So, for example, here we have stir word, and stir word is kind of an array of values, right? We have a word here which is an 8-byte value, but we're putting 8 1-byte characters into it, right? And then here we're doing a single instruction, which is not a loop, right? For stir word and char word. So Intel has SSC, where we have instructions that work upon 16-byte values. So here we have M128i. 128 refers to 128 bits, which is 16 bytes. The I here, I think, refers to integers. Let's see. Yeah, we have D, double, and stuff. But mainly for memory functions, we're going to use integers. We're going to be dealing with integers. And the reason we have double underscores here is these things are called intrinsics. They're kind of a library, functions that refer to assembly instructions usually, and they're implemented by the compiler. And things with underscores, with leading underscores, are reserved for the compiler. So if you make a function with, or an identifier with leading underscores, you shouldn't really do that, because the compiler is free to use things with leading underscores for internal usage, or whatever uses. And I think libc also does that, so you shouldn't do that. But I think you're able to do that in a limited scope, so like inside a function, inside a loop or something. So just in general, don't use leading underscores. It's just so that the compiler can know that it will not conflict with user code or something. But again, we have M128i. These things are called vectors. And then we have mmload, mmmoveMask. These are functions that work on the 16-byte vectors. So mmload is used to load from the string or from the memory into the vector. And then here we have mmcompeq to compare for equality from the string vector with the char vector. It's like this, right? And then we have this set1 API 8 to distribute the character to the 16-byte vector. Because we're comparing 16-byte vectors, the result will be an array of values represented in a vector. We usually want to turn that into a bit mask, so from bytes we turn this to bits, to a 16-bit mask, and then we can use the mask to find the location of the match with trailing 0 count U16. 16 is the 16-bit, and then we can return. Otherwise, just use the normal code. So here we are processing 16 bytes at once instead of 8 bytes at once. and then Intel has AVX2 that can process 32 byte vectors, and an AVX 512 that can process 64 byte vectors. So we may be able to make it even faster. Also, a thing to note here is load. You have load. You also have load U. The U stands for unaligned. So load requires that the pointer is aligned to the size of the vector. So P needs to be aligned to 16, but if it's not aligned, use the U variant. You also have store and store U. Store is the reverse of load, whereas load we are loading from the memory to the vector. Store stores from the vector to the memory. And for the SSC code, you shouldn't actually use this because it shouldn't be available when you have SSC, because it comes it requires BMI, which BMI comes much later than SSC. So you should probably use bit scan forward, something like that, but again, it's not the same. And for AVX2, you use MM256, AVX512, MM512. And for AVX512, you can do EPI8 mask, so you don't need to do move mask, so it automatically turns the result to a bit mask. And if you want to use the vector actually, which you can't here because it's turned into a bit mask, you can do MM512 movm, which will turn a bit mask into a byte, so it'll expand the bit into bytes. So it's kind of the reverse of move mask. And of course, see the Intel intrinsics guide. It will have all these things you want here. And of course, check this is only gonna work for SSC 2, so you should check SSC 2. I think for GCC you can do this. AVX2 or AVX512 has a lot of different versions, but the functions also has different or requires different versions. So if you want to look up whether you can use a function or what versions the function required, you can look it up here. So for example, we want to check this function. It'll say CPU ID flags AVX512BW. So it'll require a CPU flag AVX512BW, which the compiler or GCC will define this. There are a lot of functions, but for memory functions you'll generally use the integer functions. Oh, there's also set0, which is the same thing as this, but for it's like this, right? For zeros. So yeah, hopefully that makes sense.